Good evening, and thank you for joining me as I prepare to present our Week 5 Part 2 assignment for Data 620. And when I say we, I'm referring to myself, Ken Popkin, and also Willie Small and Jagdish Chabria. And as you can see in this assignment, it's pretty straightforward, which I found very gratifying as I was working through it. We had two choices: to use the machine learning repository from UCI spam-based data set or a data set of our own. We chose to use this spam-based data set that was provided. And as you can see, what we're going to do is predict spam in this exercise. So let's get started with looking at our data. When I loaded and prepared the data, it's pretty straightforward, and it's really convenient that a lot of the analysis or compilation of attributes was already done for us. So you can see that we have word frequencies, character frequencies, and some other key attributes like the length of the longest and uninterrupted sequence of capital letters. And then finally, the last column, as usual, would be to denote whether the training data set was spam or not spam. Moving right along, bringing it into a pandas data frame, no surprises there. And that went in relatively easily. You can see the most of the data frame here, and it continues to the right. From there, we chose to split our data into training and test data sets. Again, pretty standard stuff. We chose a test size to be 33% of the data. Obviously, 67% then going to training. And we used three different algorithms as we evaluated. All three performed really well, as you see as we go through this. So multinomial naive Bayes scored right around 80%. And you can see in the confusion matrix that it had, a good count, 80% obviously, of true positive and true negative. And then it also had a fairly high count of 20% of false negative and false positive, and you can see that was fairly close with 149 and 159. Logistic regression, things definitely took a big step forward. I want to come back to this step 15 when I reach the conclusion, but looking at the accuracy score and the confusion matrix, we jumped up to almost 94%, and that's definitely reflected in the confusion matrix here with our negatives dropping, our false negatives, false positives dropping to 58 and 37. And then finally, the winner of the contest of these three algorithms is XGBoost, coming in, just barely edging out the logistic regression with an almost 96% accuracy rate, which is incredibly high. Very pleased with that result, obviously. So what is our conclusion from looking through this assignment? Of the three models, XGBoost scored the best, although logistic regression, which is a much lighter algorithm to run as far as intensity and resource consumption, came in very close to it with the 94% versus the 96%. And one thing I want to come back to is to show that in logistic regression, when I ran a test to see how many of the results would be kept versus dropped, it actually recommended that I keep all 57 columns. So not sure if that is typical, or I should say I know that that's not typical, but it appears that all of our columns were very relevant in coming up with the score that we did in the 90 percentile, like I shared earlier. With that, this assignment, like I said, was very educational, but also very straightforward, and I did have an enjoyable time working on it and also getting the opportunity to share it in this video. Thank you for listening.